In our lesson so far, we have seen how we can work with pointers in some of the basic scenarios, but there are some scenarios where pointers can be really puzzling. And one such scenario is when we want to use pointers to pointers. So in this lesson, we are going to see how we can use a pointer to pointer. Let us assume that this is a logical view of computer's memory, and each partition here is 1 byte of memory. Now we know that each byte of memory has an address. We have drawn the memory horizontally here. Let us assume that the address increases as we go from left to right. So if this byte is at address 200, the next byte would be at address 201, and the next byte would be at address 202, and so on. Now let's say in my program I have declared an integer variable named x, and maybe I have initialized it as 5. And now when the program will run, some amount of memory will be allocated for this variable x. In a typical architecture, in a typical compiler, integer is stored in 4 bytes. So 4 bytes will be allocated for x. So let's say these 4 bytes at address 225, this block of 4 bytes starting address 225 is allocated for x, and the value stored in this block of 4 bytes for x is 5. Now the next thing that I want to do is I want to declare a pointer variable that will store the address of x. Now to store the address of an integer, we will have to declare a pointer to integer, something like this. We need to put an asterisk sign in front of the variable name. Now what will happen is that some amount of memory will be reserved for this variable p. In a typical architecture, pointer is also stored in 4 bytes. So let's say we get this block of 4 bytes at address 215 for p, and now I want to write a statement like this. So I want to fill in the address of x in p, and that's how p points to x. Ampersand operator gives us the address of a variable. Now one important thing here, we are able to store the address of x in p because p is of type pointer to integer. If p was of type pointer to character or pointer to some other variable, this statement p equal ampersand x would not have been valid. So if I have to write down the types of these two variables, then x is an integer and p is pointer to integer, or I can also say that p is int star or int asterisk. And why pointer variables are strongly typed? Why do we need a pointer to integer to reference or store the address of an integer? It is because we don't just store the address of a variable in a pointer variable. We also use the pointer variable to dereference the address and write some value there. So if I write a statement like this value here at address 225, this x is now modified. Now can I create a pointer to this variable p, which itself is a pointer to integer? Well, yes, we can do so. So let's say we want to create a variable named q that will store the address of p. Now what will be the type of this variable? We need a pointer of a particular type to store the address of a particular type of variable. So to store a pointer to integer, we will have to say that we want a pointer to pointer. So we will put 2 asterisk sign in front of the variable name, and now this variable q can store the address of p. So with this first line, with this int asterisk asterisk q, we created q. Let's say we created q at 205, and now we are saying that q will store the address of p. So q points to p, and the type of q is int asterisk asterisk. We put 2 asterisks. Simple way to read this is that the type of variable x is integer. So to store the address of x, we will need a pointer of type int star. So we will put 1 star to say that this is a pointer to that particular type. And to store the address of p, we will need a pointer to int star. So we will put 1 extra star to say that this is a pointer to int star. And we can go on like this. Let's say we want to declare a pointer to pointer to pointer. So int asterisk asterisk is pointer to pointer, and we will put 1 more asterisk We can put these 3 asterisk immediately after this keyword int, or we can put it immediately before the variable name like we have done in the case of q here. Let's say we define r as int star star star. So let's say r gets this address 230 in the memory. Now r is of type int asterisk asterisk asterisk, so it can store the address of int asterisk asterisk. So it cannot store the address of x or p. Only a statement something like r is equal to ampersand q will be valid. Now I have translated my previous rough code into a working C program. Let us assume that this program is working as per this memory sketch that we are showing in the right. Now I will write some print statements and you need to guess the output. So basically you have to assume that these variables x, p, q and r are allocated these addresses what we are showing here in the right. So the first print statement that I'm going to write is I want to print asterisk p, and this one should be simple for you. Asterisk p would be value stored at address in p, so this will be 6. Now the next statement that I want to print is asterisk q. So asterisk q will be a value at address stored in q. Address stored in variable q is 215, so this is nothing but the value of p, so this will be 225. And now I want to print asterisk asterisk q, so I want to do dereferencing twice. First I want to go to asterisk q is this address 225, and now I want to look at the value at address 225, so this one will be 6. We could have avoided writing this parenthesis here. We could have said asterisk asterisk q only, and that would have also that would have meant the same, but it's a good practice if we are using this asterisk operator to use parenthesis wherever we can do it, because sometimes when we are also using other operators we are not sure about the precedence and we want to avoid unwanted behaviors. Now what about these two print statements, asterisk asterisk r and asterisk 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 r? Asterisk r means value in q, which will be 215, and then further one more dereferencing will take us to value in p, which is 225, and one more dereferencing will take us to value in x, which will be 6. If you see, this is really interesting. From r we are using one asterisk operator and we are able to go to q, then we are using the asterisk operator twice and we reach p, and then we are using the asterisk operator thrice and we reach x. Let's make some more changes in this code and run this in a real compiler. So what I'll do here is I'll write a statement like this, and then after this statement I'll print the value in x. If you run this now, as you can see, asterisk p, asterisk asterisk q and asterisk 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 r, all these three values are 6. The address will not be same as we had shown in the example for obvious reasons, and as you can see we are able to modify x by doing this chain of dereferencing using this variable r. If we would write something like asterisk asterisk q is equal to let's say something like this. Now asterisk p is also referencing x, and asterisk asterisk q is also dereferencing x. Sorry, we are dereferencing here. So any guesses what will be the output of this last print statement? Well, if you see, x is incremented by 2 here. So this was pointer to pointer. I recommend that you write some of this code yourself and play a little bit. In the coming lessons we will use pointer to pointer in some real problem scenarios. So thanks for watching.